In this video, we will be going over a block and cable system as shown in figure Q1A. The first part of the question is asking us to draw a free body diagram of the system shown in A, so let's go ahead and do that. So question Q1A, part I. As we're being asked to draw a free body diagram of A, which is this part here, let's go ahead and draw our pulley, like so, and let's add the forces experienced on that pulley. So we have our tension force T, which is being supplied by B, this bit here. We'll write that in as TB. And we also have a force P acting on the pulley, which we will just simply write as P. And we also have this mass, which is acting on the pulley, which we will label as mg, as mg is a force, i.e. the weight, and mass is not a force. So mg is the gravitational force experienced. And let's also add in the angles at which these forces are working at. I have not made this quite big enough. However, I do advise going forward to make your diagrams as big as possible. I have the ability to zoom in here, so let's go ahead and just zoom in and annotate as necessary. So we have angle theta, and we also have P acting at 30 degrees below the horizontal. And that's us done part I of this question. Moving ahead to part II of this question, we've been told that if a block has a mass of 550 kilograms and P is a force of 6,000 newtons, we're being asked to determine the angle and the force in cable AB, which is this part of the cable. So if we investigate the forces acting on our pulley system, because we have been told that our system is in fact in equilibrium, that means that nothing is in motion, and so all forces, the sum of all forces in all directions, should be zero. So let's go ahead and assess the forces acting in each direction. Wrong pen. The sum of all forces in the x direction, which is, let's label, we have y and we have x. The sum of all forces in the x direction is going to be TB cos theta, as we have, if we remember SOHCAHTOA, CAH, we have adjacent hypotenuse. This is our hypotenuse here. And we also have our adjacent, which is the blue horizontal. And we have our right angle triangle. So we're going to use cos theta there. And then we also have acting in the horizontal direction P at 30 degrees, which is similar to T. So we're going to say that is equal to, because it is acting in the opposite direction. If we draw in our y-axis, let's do this in blue again. We have T acting in this direction, and we have P acting in this direction. We're going to say that this is equal to P cos 30. Note that I haven't put in the forces yet, as we want to just get our variables and our equations down, and then we can start substituting it. Let's do the same for the y direction, which is slightly more involved. We have sine theta this time, which is going to be equal to P sine 30 plus our weight, mg, as we are acting downwards. So this equal sign, imagine like some sort of balance or a scale, where in order to keep this equation balanced here, we want to imagine that in order for these two things to be equal, if we take one away from the other, i.e. the sum of all forces is 0, then we have TB on one side balancing our balance, cos theta, and we have P cos 30 also balancing out. And let's take this a bit further forward just to reinforce this. We'll see that if we rearrange our equation for the sum of forces in the x direction, we will see that we get TB cos theta minus P cos 30 is equal to 0. So again, the sum of all forces is equal to 0, i.e. we are in equilibrium. And also note that this negative sign tells us that P cos 30 is acting in the opposite direction to TB cos theta. Okay, so moving forward, let's just go to the question and reassess what we are being asked to find here. We're being asked to find the angle theta and the force in cable AB. So let's start with the easier of the two, and that's to find the angle. Hopefully we remember that tan theta is equal to sine theta divided by cos theta. And also note that we have sine theta and cos theta. So we can do a bit of rearranging, and we'll find that if we do TB sine theta over TB cos theta, we're going to get tan theta. But we know what TB sine theta and TB cos theta are equal to. So through a further bit of rearranging, we can say that tan theta is going to be equal to P sine 30 plus mg divided by P sine of 30. Fantastic. And finally, to find our angle, we'll rearrange and say that inverse tan, or the arc tan, will give us our angle P sine 30 plus mg divided by P sine, P cos 30. Let's just double check that I haven't made that mistake anywhere else. We've made it up here. Cos 30. And that all seems good to go. So that's us found our angle. And then to find our force TB, once we have found our angle here, just through a bit of substitution, back in to this above equation. So if we take TB cos and our newly found theta, and say that that is equal to P cos 30, through some clever rearranging, we can say that TB, or remember our tension from our free body diagram up here, is simply going to be equal to P cos 30 divided by cos theta. And I would advise that at this stage here that we've just done in red, that it's okay to keep this angle of theta to 3 significant figures, which will be fine, as that will carry over enough detail. And finally, the thing to remember that once we have found our TB, that we also write that in kilonewtons. I believe it's up to you to plug in the values, and hopefully we get the correct answer. So there we go. That is us having assessed the block and cable system in question 1.